Good afternoon. Today I'm going to talk about week 2 of X-ray physics, and what I'm going to do is just tell a story of how X-rays are produced based on my tube here, my beautiful tube. So first we have a heating of the short and long filaments in the cathode, and that's going to be heated by units of MA. The units of MA are going to determine which filament is heated to produce electrons. So I apply my heat and my units of MA shown here, and the electrons on the filaments are going to start to separate. This separation of the electrons from the filaments is called thermionic emission, and this is going to create a space charge in between the cathode and the rotating anode. And after the space charge has been established, we're going to apply another unit, which is called kVp. kVp is going to accelerate the electrons from the cathode over to the anode in order to produce X-rays. If we don't have the right amount of kVp, this process is not going to happen. Once the electrons reach the focal spot on the rotating anode, this is when X-rays are going to be produced in all directions. The emission of X-rays is going to be called isotropic emission. So thermionic emission is when we have electrons initially being separated from their filaments, and isotropic emission is when we have X-rays being produced from the focal spot on the rotating anode. Okay. Now when we produce X-rays on the focal spot, that can happen in one of two ways, either by Bremsstrahlung or by characteristic X-ray production. Bremsstrahlung production is the most common way that X-rays are produced. It's about 90%, and characteristic occurs about 10% of the time, but they do happen at the same time. During Bremsstrahlung X-ray production, we're going to have a projectile electron traveling in a certain direction past the nucleus. However, once it reaches the nucleus, it's going to be deflected in a different way. Electrons have a negative charge, the nucleus has a positive charge. It's my positive sign right here. So as a result of this attraction, it's going to be deflected from its original path, and the energy is going to be lost from this electron. So once this is deflected the opposite way, a photon is going to be released. And that's our X-ray. So that's Bremsstrahlung X-ray production. The next way is called characteristic production, and our projectile electron is going to come in and replace an electron all the way on our K shell of our electron cloud. So it's going to kick out an electron from here, and another electron from another shell, one of these other shells, is going to come in and replace it. Now as we go up in our electron cloud, we're going up energy levels, so these have higher energy than these electrons in the K shell. So as a result, these are going to be losing energy as they're going down into the electron cloud. So this way an X-ray is produced from the loss of the kinetic energy of the replacement electron. Okay? Okay, that's Bremsstrahlung and characteristic X-ray production. The next topic we talked about in class was rectification. And essentially we need rectification in order to convert an alternating current to a direct current, because a direct current is the only way that we can actually produce X-rays. So I'm not going to talk about everything because all of it is in the handout, but I'm just going to highlight a few things. And I'm sorry that this bled through. I hope it's not too hard to see. This is our regular sine wave that we're comparing all of our currents to when we're talking about rectification. So our sine wave looks like this. It's going in the positive direction, the negative direction, and so forth. During half-wave rectification, all we're doing is we're cutting off this bottom portion of the sine wave, so we only have the positive portion of it. And as a result, we have gaps where X-rays are not being produced. During full-wave rectification, what we've done is we've inverted the sine wave so that we don't have very many spaces in here, but we still have a few gaps in these small areas. During three-phase, what we're doing is we're combining 3 full sine waves, and here our graph becomes a little bit more condensed. So we have less space in between where we're producing x-rays. And the last one, I didn't draw it, but it's called high frequency. Basically, we're combining 3 waves and superimposing them on one another so that we have very little space in between where x-rays are produced. That's pretty much the best option for most chiropractic offices because you can plug that directly into the wall. It'll convert the 100 hertz, it'll convert the 60 hertz to the 100 kilohertz current, and that's feasible for just a regular outlet plug. It also limits the amount of patient exposure that we have, unlike with these, where we have too much space in between where x-rays are being produced. We have very little space, so all we have to do is expose the patient and we have x-rays. We don't have to do it for a very long period of time. That's pretty much it for week 2. Have a good day.